Hello students, welcome back to digital classes. In this session, we are going to learn the interesting and important topic logarithms. So by the end of the session, we are going to learn what is logarithm, conversion exponential form to logarithm form, vice versa logarithm form to exponential form, and also properties of logarithms, problem solving related to logarithms. Let us recall what we have studied in the previous classes, the laws of exponents. If a comma b are non-zero real numbers and m comma n are integers, then we know the formula a power m into a power n is equal to a power m plus n. If the bases are equal powers, we should add the powers. So if you take an example 5 power 3 into 5 power 4, then we can write adding the powers 5 power 3 plus 4. The second formula ab whole power m is equal to a power m into b power m. So the example, if you see 5 into 3 whole square is equal to 5 power 2 into 3 power 2. The third one is a by b whole power m is equal to a power m by b power m. If you see the example 5 by 3 whole power 2 is equal to, I can write 5 power 2 by 3 power 2. Fourth formula a power m to the power of n is equal to a power m into n. So example, if you see 5 power 3 whole square is equal to 5 power 3 into 2, which will become 5 power 6. And also a power 0 is equal to 1. The example, if you see 5 power 0 is equal to 1. And the sixth one a power minus m is equal to, I can write, if the in the power minus is there, it will come into the denominator, that is a power minus m is equal to 1 by a power m. The example is 5 power minus 2, which you can write as 1 by 5 square. Now let us see why the logarithms have been introduced. Let us observe the following: 2 power 1 is equal to 2. Here we can say 2 is raised to 1 to get 2. So 2 power 1 is equal to 2 means 2 is raised to 1 to get 2. Same way, if I write 2 square is equal to 4, what we can say? 2 is raised to 2 to get 4. 2 power 3 is equal to 8. This we can say as 2 is raised to 3 to get 8. So what we can say here, 3 is called power or exponent or index, and the base, this 2 is called the base. So 2 cube is equal to 8. What we will say? 2 is raised to 3 to get 8, where 3 is called power or exponent or index and 2 is called base. Now let us see exponential form. If 2 power x is equal to 32, then what is the value of x? Then now you write this 32 also in the exponential form. While writing 32 into the exponential form, you can write 2 into 2 into 2 into 2 into 2, which is equal to 2 power 5. Then what I can write is 2 power x is equal to 32, we can replace by 2 power 5. So 2 power x is equal to 2 power 5. So here what we can say is, if bases are equal, powers also can be equated. So 2 power x is equal to 2 power 5 means x is equal to 5. Now the form a power x is equal to n is called exponential form. If a power x is equal to n, the form is called exponential form, where a is called base and a should not be equal to 0 and a always greater than 0, and x is called power or index or exponent. By using the exponents, can we able to find the value of x for 2 power x is equal to 5? What does it mean? What is 2 power x is equal to 5 means? What should be the power to which 2 must be raised to get 5? That means for what value of x 2 power x becomes 5? Let us check. 2 power 1 is equal to 2, 2 power 2 is equal to 4, 2 power 3 is equal to 8, 2 power 4 is equal to 16. So it is increasing. So we are not getting 5 here. 2 square is equal to 4 we got, and 2 power 3 is equal to 8, and 2 power 4 is coming to 16. So 2 power 5 is 32, which is crossing the 5. So what we can observe here, 5 lies between 2 square and 2 cube. So what we can say here is 5 lies between 2 square and 2 cube, as we cannot find the value of x with exponents. So we need a special relation, that is, therefore we need to establish a new relation between x and 5. As we cannot able to find the value of x with 2 power x is equal to 5 with exponential form, we need a new relation. That relation is, in such situation, logarithm has been introduced. So if you observe, if 2 power x is equal to 5 and this power is equal to, we can say as then x is logarithm of 5 to the base 2. This is logarithm of 5 to the base 2. So to finding the value of x, we need a new relation, that is logarithm. So we are applying logarithm to the 5 and the base is 2, and it is written as log 5 to the base 2. So x is equal to log 5 to the base 2. So always remember children, we will read this as log 5 to the base 2. So always this base should be subscription, the base should be subscription. So log 5 to the base 2. So always we should read it as x is equal to log 5 to the base 2. In general, if a power x is equal to n, then x is equal to log n to the base a. Observe here students, this is exponential form and this is a logarithm form. So always a power x is equal to n, if exponential form is given, to convert into logarithm, the power is equal to, we always write power is equal to log n to the base a. So this x becoming x is equal to log n to the base a. So in the left hand side, in the exponential form, the base a is there and this base a becoming the base to the log. So we can say a power x, if a power x is equal to n, then x is equal to log n to the base a. So what is the value for a and all? Where a and n are positive real numbers and a should not be 1. Here the most important condition is the base never should be equal to 1 and a should not be 1. Let us see the graph of y is equal to 2 power x and find the value of x for 2 power x is equal to 5. For this we compute the value of y by choosing the some value for x. Now let us see the graph. Before going to the graph, let us see the values of the graph. First x and y is equal to 2 power x. Let us take x is equal to 0. If x is equal to 0, y is equal to 2 power 0, which is equal to 1. Let us take x is equal to 1. If x is equal to 1, y is equal to 2 power 1, which is equal to 2. If x is equal to 2, y is equal to 2 power 2, which is 4. If x is equal to minus 1, so if we are taking 0, 1, 2 and 3, if x is equal to 3, y will be 2 cube and 8. It is increasing 1, 2, 4, 8 like this. Now let us take the negative values. So if I take x is equal to minus 1, y is equal to 2 power minus 1. 2 power minus 1 is 1 by 2, which we can write as 0.5. Minus 2, if I take x is equal to minus 2, y is equal to 2 power minus 2, which is equal to 1 by 4, which we can write as 0.25. Now if we take x is equal to minus 3, then y is equal to 2 power minus 3, then 1 by 8 is equal to 0.125. If we observe that if the value is decreasing, then the y value also decreasing, but it will never touch the 0. Let us see the graph here. So this is the graph for y is equal to 2 power x. The points, if x is equal to 0, y is equal to 1. If x equal to 1, y is equal to 2. If x equal to 2, y is equal to 4, and x is equal to 3, y will be 8 here. If you take the negative side, if x equal to minus 1, y is equal to 0.5. X equal to minus 2, y is equal to 0.25. If x equal to minus 3, y is equal to 0.125. So on it is going like this. If you take x equal to minus 10 also, it will not touch the x axis. So what we can conclude is the curve comes closer to the x axis, but neither touches nor cuts the x axis. So if 2 power x is equal to 5, then x is equal to log 5 to the base 2. So if you observe the graph here, y is equal to 5 if we take, so in the y axis 5, draw the parallel line which is touching the graph, and now draw the perpendicular line here which is touching the x axis at D, and this D is called the x value, which we can say this value of x is called logarithm of 5 to the base 2. Types of logarithm. So based on the base we will define the logarithms. Two types, one is common logarithm and next one is natural logarithm. So if the base is 10, we will say that is a common logarithm. If the base is e, then that is called natural logarithm. Example, log 20 to the base 10. So if the base is 10, we will call the logarithm is common logarithm. If the base is e, the logarithm is called natural logarithm. So generally we will take the common logarithm only like this, log 20. We don't write the base value here. If we are not writing the base value, means that is invisible 10 is there. So simply we will write log 20, then we can assume that log 20 to the base 10 is there, which is invisible here. So the common logarithm, the base is 10, which we can write easily log 20. And for the natural logarithm, the example is log 20 to the base e, which we can write in the short form ln 20. Instead of writing log 20 to the base e, we can write in short ln 20. ln 20 is nothing but natural logarithm of 20. So whenever we say natural logarithm, the base is e. Here we should note one thing, log x to the base 10, we can write in short log x. So we are not writing 10 base here, and log x to the base e is equal to ln x. So this is the short form of log x to the base e, and log x is the short form of log x to the base 10. Now let us see what is exponential form and what is logarithm form. So a power x is equal to n is called exponential form, and x is equal to log n to the base a is called logarithmic form. So exponential form, a power x is equal to n is called exponential form, and x is equal to log n to the base a is called logarithmic form. Now let us see the conversion from exponential form to logarithm form and logarithm form to exponential form. Let us see some example based on this. Problem, write the following in logarithmic form. The first question is 2 is equal to 7 power x, and second question is 1 by 81 is equal to 3 power c. So if you observe students, this is in the exponential form, we need to write into logarithmic form. First let us solve the first problem, 2 is equal to 7 power x. So 2 is equal to 7 power x, I can write as 7 power x is equal to 2. So I am converting this to use the formula a power x is equal to n. If a power x is equal to n, then x is equal to log n to the base a. So whatever the power is there, the power is equal to, I am sending a to the right hand side, it will become log n. So the base a becomes base of logarithm. So always remember student, a power x is equal to n means the power is equal to, whatever the power is there, the power is equal to, I will write log n to the base a. So if you observe 7 power x is equal to 2, what is the power here? Power is x. So always I should write the power x is equal to log 2, and this base 7 will become base of 7. So if you observe this, we can write x is equal to log 2 to the base 7. So the power is equal to log 2 to the base 7. So always we will write power is equal to logarithm. And the second problem, 1 by 81 is equal to 3 power c, which is also we can write as 3 power c is equal to 1 by 81. Same formula, if a power x is equal to n, then x is equal to log n to the base a. So what is the power here? Power is c, right? So we should write c is equal to log 1 by 81 to the base 3. So we will write as c is equal to log 1 by 81 to the base 3. Further we can simplify this after studying the properties of the logarithm. Now let us see one example based on the logarithm form to exponential form. Now let us see one problem relating to logarithm form to exponential form conversion. So problem is, write the following in exponential form. First problem, log 100 to the base 10 is equal to 2, and second problem, log 2 to the base 2 is equal to 1. Let us solve the first problem, log 100 to the base 10 is equal to 2. This is in the logarithm form. Now if log n to the base a is equal to x, then n is equal to a power x. This is the logarithm form, this is the exponential form. What we are doing while converting logarithm to exponential form, we are removing the logarithm from here, and whatever the base is there, this base is becoming base of a. So n is equal to a power x. If you observe log 100 to the base 10 is equal to 2, now I should write 100 is equal to this base 10 will become base of 2, that means 100 is equal to 10 square. So I can write 100 is equal to 10 square. This is the exponential form of log 100 to the base 10 is equal to 2. Logarithm form to exponential form, let us see the problem, log 100 to the base 10 is equal to 2. Here if log n to the base a is equal to x, then n is equal to a power x. So which we can write log n to the base a is equal to x means logarithm we will remove here and sending a to the right hand side, which will become a power x. Same way log 100 to the base 10, while converting to the exponential form, 100 is equal to this base will become base of 2. So 100 is equal to 10 square. Now second problem, log 2 to the base 2 is equal to 1. Let us convert this to exponential form. Log n to the base a is equal to x, then n is equal to a power x. So which we can write this 2 is equal to base sending to the right hand side by becoming the base of this. So 2 is equal to 2 power 1. So if you replace 2 by a, we can write a note here. If the bases are same, the value of log will becoming 1 here. Same way we can generalize this by using this log a to the base a is equal to 1. So always if the log value and base value is same, we can say the value is 1. So this is the proof for that. Log a to the base a is equal to 1, and note 2, log 1 to the base a is equal to 0. So always log value irrespective of base is equal to 0, and the base should not be equal to 1. So only one condition, a should not be equal to 1 and a is greater than 0, then log 1 to the base a is equal to 0. Now note 3, log 0 to the base a does not exist. So whatever the base is there, log 0 does not exist. Why it is does not exist? Log 0 a is equal to x, if we suppose 0 is equal to a power x. So a power x is equal to 0. Is it possible? Let us see. For no value of x, a power x will become 0. If x value decreases, the value of a power x is decreases very close to 0, but never attains the value 0, because as we have seen in the graph, if x value decreases, the value of a power x decreases very close to 0, but never attains the value 0. So that is why log 0 does not exist. Now let us see one example based on this. Log 32 to the base 2 is equal to x. Log n to the base a is equal to x, then n is equal to a power x. 32 is equal to 2 power x, we can write. 2 power 5 is equal to 2 power x. Already we have seen this. X is equal to 5. If bases are equal, powers also equal. X is equal to 5. Now let us see properties of logarithm. Let a comma x comma y be positive real numbers and a not equal to 1, m comma n are any real numbers, then log xy to the base a is equal to log x plus log y. So always log xy is equal to log x plus log y, which is called product rule. What is product rule? Log xy is equal to log x plus log y. So example, log 2 into 3 is equal to, we can say log 2 plus log 3. Here you should observe the base always same. Now the second property, log x by y is equal to log x to the base a minus log y to the base a. This is called quotient rule. Log x by y is equal to log x minus log y. The example, log 2 by 3 is equal to log 2 minus log 3. Now the third property, log x power n is equal to n log x to the base a. So this is the power rule. While doing the power rule, what we are writing here, log x power n is equal to n log x. Whatever there in the power, it will come to the coefficient of the logarithm. Let us take one example. Log 2 to the power of 5 is equal to, I can write whatever there in the power will come to the coefficient of logarithm. So the power rule is log x power n is equal to n log x. Some more properties of the logarithm, log x to the base a power m. So here if you observe, the power is in the base. So whenever the power is in the base, it will come as 1 by m log x to the base a. Let us take one example, log 2 to the base a power 5. So here power is there in the base, so it will come in the denominator of the coefficient of logarithm, which is equal to 1 by 5 log 2 to the base a. The next property, log x power n to the base a power n. Here log value is also having power and the base is also having power. In this case we will use the formula n by m log x to the base a. So the power is there in the logarithm value will come in the numerator and the power which is there in the base will come in the denominator. Example, log 2 power 3 to the base a power 5 is equal to 3 by 5 log 2 to the base a. We know that if 7 is equal to 2 power x, then x is equal to log 7 to the base 2. We can use by exponential form 7 is equal to 2 power x. While converting, we can write x is equal to log 7 to the base 2. Then what is the value of 2 power log 7 to the base 2? Proof, consider 2 power log 7 to the base 2. So here log 7 to the base 2 value is x. From here we can say x is equal to log 7 to the base 2. Here we can substitute in the place of log 7 to the base 2, I can write x. So which is equal to 2 power x, since log 7 to the base 2 is equal to x. So now what is the value of 2 power x? In the question it is given 2 power x is equal to 7, which is equal to 7, since 2 power x is equal to 7. So finally I can write 2 power log 7 to the base 2 is equal to 7. So we can generalize this by replacing 2 by a. The generalizing is a power log n to the base a is equal to n. The base and the log base both are same. We can say the value is always equal to n only. A power log n to the base a is equal to n. Now let us see some values of the logarithm. So log 2, log 3. So log 2 value is 0.3010 and log 3 value is 0.4771. So these two are irrational numbers. So log 2, log 3, not only log 2, log 3, log 4 value, log 5 value, all are irrational numbers only. Here base is not given. If base is not given means the base we should consider as 10. So log 2 value is equal to 0.3010. Now if you observe 0.3010, 0 is called integral part and 3010 is called decimal part. So now 0 is called integral part and this integral part, which we will call it as characteristic of logarithm. So 0 is called the characteristic, and if you observe 3010 is a decimal part and this decimal part is called as mantissa. The integral part is called characteristic and the decimal part is called mantissa. Now let us solve the problems related to logarithms. Determine the values of the following: log 5 to the base 25. Solution: log 5, 25 can write as 5 square. So now is equal to 1 by 2 log 5 to the base 5. The formula which we used is this one: log x to the base a power m is equal to 1 by m log x to the base a is equal to log 5 to the base 5 value is 1, right? So 1 by 2 into 1, which is equal to 1 by 2. Now 2 power 2 plus log 3 to the base 2. Solution: given 2 power 2 plus log 3 to the base 2, here it is in the form of a power m plus n. So a power m plus n I can write a power m into a power n. So 2 square into 2 power log 3 to the base 2, 2 square is 4 and this is, we know the formula, which is equal to 3. So the formula is a power log n to the base a is equal to n. So 4 into 3 is 12. Expand log 128 by 625. Consider log 128 by 625, log 128 minus log 625. We are using the formula log x by y. So log x minus log y. Log 2 power 7 minus log 5 power 4. Again I am using here power rule: 7 log 2 minus 4 log 5. So this is the value of the expansion of log 128 by 625. Log 128 by 625 is equal to 7 log 2 minus 4 log 5. So here the single logarithm we made into multi-logarithm. The next problem, let us see the multi-logarithm into single logarithm. So the problem is, write 2 log 3 plus 3 log 5 minus 5 log 2 as a single logarithm. Solution: this is given, which we can write by using the power rule. I can write log 3 square plus log 5 cube minus log 2 power 5. So this is the power rule which we have used here. 3 square is 9, log 9 plus log 125 minus log 32. Now here you use the product rule: log 9 into 125 minus log 32. Again log 9 into 125 is log 1125 minus log 32. By using the quotient rule, it will become log 1125 by log 32. So here the multi-logarithm converted into single logarithm. Now let us see one more problem. This is an important problem. If x square plus y square is equal to 25xy, then prove that 2 log x plus y is equal to 3 log 3 plus log x plus log y. So given question is x square plus y square is equal to 25xy, then prove that 2 log x plus y is equal to 3 log 3 plus log x plus log y. We can solve this problem using two methods. So let us see one method here. Proof: consider the left hand side 2 log x plus y, which we can use by power rule. I can write as log of x plus y whole square. So x plus y whole square, expanding this, x square plus y square plus 2xy. So x square plus y square given in the question as 25xy. So if I substitute here log 25xy plus 2xy, so log 25xy plus 2xy becomes 27xy, log 27xy. Now I can use the product rule, log xyz is equal to log x plus log y plus log z. So we have seen the product rule as log xy is equal to log x plus log y. We can even expand this to 3 variables, that is log xyz is equal to log x plus log y plus log z, which is log 27 plus log x plus log y. So log 27 I can write as log 3 cube plus log x plus log y. Again use here the power rule, which is equal to 2 log x plus y is equal to 3 log 3 plus log x plus log y, hence proved. You can even solve this problem using the second method. So students, solve these problems, find the value of log 128 to the base root 2, and if x square plus y square is equal to 10xy, prove that 2 log x plus y is equal to log x plus log y plus 2 log 2 plus log 3, and third one is x square plus y square is equal to 27xy, then show that log x minus y by 5 is equal to 1 by 2 log x plus log y. For better understanding of the concept, solve the worksheets. Please visit the official website of SCRT for worksheets. Thank you. We will meet with the interesting topic in the next class. Thank you students. Thank you very much.